Alright, so this is a video over, I don't know, I guess this is like the most difficult elastic problem that I could come up with, so that's what this video will be over. Now, I'm actually concerned that I'm not recording because I can't see this like I usually can, so I need to move that. Okay, I am recording, this is good. Alright, so, there. What we've got here is you've got these two objects, and we're supposed to figure out the velocity and angle of this one after all the collisions have occurred. Now, first thing that you've always got to do is find the total x and the total y. I'll start with total x momentum. The total x momentum is going to be essentially this piece of this vector plus this piece of this vector. Now, they're vectors and they're in opposite directions, so they'll actually be subtracting from each other. To get the two sides of this, maybe you can't see it, but this is definitely a triangle here, and this is a triangle here. You can extend it out and see that. But to get the two sides of these triangles, the two horizontal sides, we're going to have to use cosine. So for this one in the top, I'll start with this one, because this is like the positive direction, so I'll start with this one. So for this one, and the other thing you really want to do is, if you're not careful, you're going to do 4 times the cosine of 15, and that's not going to be correct. You need to change this to a momentum, right? P equals mv. So 25 kilograms, 4 meters per second. This is 100 kilogram meter per second. Alright, so 100 is our hypotenuse. In this case, our hypotenuse is going to be 4 kilograms times 2 meters per second. So this one's going to be 8 kilogram meter per second. Alright, and so what we've got here is the x momentum, this piece right here. You can find it by taking 100, which is the hypotenuse, times the cosine of 15. And when you're doing this problem, you want to make sure that your calculator is set to degree mode. If it's in radians, you will not get the correct answers. 100 times cosine of 15 gives me 96.6 kilogram meter per second. So I've got 96.6. I'm going to have to work fast because this is going to take a while. And then this side right here, same thing, except this is 25 degrees. So I'm going to take 8 times the cosine of 25. And I get 7.25. So we got 96.6 minus, because it's in the other direction, 7.25. And when I do that, I get 89.35 kilogram meter per second. So this is the total x. The total y is going to be similar. Let me do it in a different color. The total y is going to be similar. The only difference is for the total y momentum, instead of it being, the cosine, you're going to take the sine of all these. So it's the exact same thing. It's still the hypotenuse. It's just sine 15. So here you've got 100 times the sine of 15. This is, again, our positive because it's going up. So this is going to be our positive one. So I've got 100 times the sine of 15 degrees. And I get 25.88. So I got 25.88 minus this thing is, you're going to take 8 times the sine of 25 degrees. And 8 times the sine of 25 gives me 3.38. So I'm going to subtract those, and I get for the total x, or the total y, the total vertical momentum is just going to be 22.5 kilogram meter per second. And this is all I really want on this side of the problem. These are two very important numbers, so we're going to keep them here. And now we're going to start to analyze this side over here. Okay. Let's look at this. Again, this 2 meter per second will mess you up, so don't use it. Just take the momentum. So take 2 times this object, which we can see from before was 25. So really this side is now 50 kilogram meter per second. And we're just going to break this up into the components, the horizontal and the vertical component. The horizontal component, I take 50 times the cosine of 35 degrees. And I get 40.96 basically, so 40.96 kilogram meter per second. If I ever forget my unit, it's all the same, but I just get tired of writing it out. The vertical, on the other hand, is going to be 50 times the sine of 35 degrees. Now, something interesting here is before this object was moving up, but now it's apparently moving down. So this is, I'm only going to write 28 point, I got 28.68. I'll call it 28.68, I guess. But understand that this is actually going to be sort of negative. I'm not writing negative on here because that will mess me up later, but I do have to recognize that this is going to be in the downward direction. And we'll get to that in a minute. But now let's look at this object here. I honestly don't know which way it's going to go. It could be going left, could be going right, might be going up, might be going down. I'm not sure yet, so I'm not actually going to draw anything. Instead, I'm going to go ahead and start to try to figure out components of this one right here, right? For example, whatever, I'm just going to really quickly give us a number system. Let's call this 1, 2, this is object 1, this is object 2. So for object 2 here, if I was going to say the x momentum of object 2, that's what I'm going to call the x momentum. And I don't know if it's going left or right. So that's my goal, to try to figure out what is the x momentum of object 2. Well, I do know the x momentum of object 1 here is 40.96. Okay, so let's start there. 40.96, let's do, I'm running out of space, let's do px here. The total x momentum on this side is going to be equal to this one, 40.96, plus this mystery one. I don't know what this is, right? So whatever this is, though, I know that when I add these together, because these are only two pieces of x momentum, that it still has to be the same as before. This is the conservation of momentum. This is the whole underlying principle behind this entire problem, is that if it's 89.35 before, it's still got to be 89.35 afterwards, regardless of what else happened. And this is nice because I just have a little equation here, right? I just solve for px2. So I subtract 40.96 from both sides to get px2 by itself. So minus 40.96 minus 40.96. So 89.35 minus 40.96 gives me 48.39. So px2, px2 is on the other side, right? px2 is equal to 48.39 kilogram meter per second. And notice that I was careful with my signs, right? This was positive, but the net was positive, so it must be in that direction. So I already know one side of this thing's triangle, right? It's actually pretty comparable to this one down here. It's a little bit bigger, but this thing must be, and again, these are momentum triangles, not velocities. This side, and I don't know if it's going to go up or down yet, but this side has to be 48.39 kilogram meter per second. I really need more space, so if you need to pause and write this down, you can pause at this point in the video, but I'm going to erase this work up here. I just want you, so you can pause if you need to pause and understand where this is coming from. But again, I just use the total x momentum from this side to figure out this piece of x momentum using what we already knew. Alright, I'm going to erase it. Now, I'm going to treat the total y momentum the exact same. There is a difference, though. This time, this piece of x momentum is going down, or the y momentum is going down, so it's going to be subtracting from the total. Right? So it's going to look something like this. Whatever this piece is, I don't know. Again, I'm going to call it py2 this time. So the total y momentum, py total, is going to be equal to, let's just start with this piece, and it's negative, right? So negative 28.68 plus, I have no idea if this is negative or positive, so I'm just going to put py2, whatever that is. We'll figure out if it's positive or negative in a second. And when I add those together, that's the total. But of course, again, the total y momentum from before must be 22.5, positive 22.5. So this has got to be equal to 22.5. Again, we found a nice little linear equation. I guess it's linear. And you add 28.68 to both sides. So plus 28.68 plus 28.68. So I have 22.5 plus 22.68, 28.68, sorry. And I get 51.18. So this is 51.18 kilogram meter per second. And it is positive, right? We were very careful with our signs, so we know it's positive. Therefore, we know that, and I need to kind of move this out of the way because I'm going to draw. Let's see if I can do this. All right. Yeah. Okay, that 2 got lost, but I'll just move it back over. All right, so I know that this a vertical component. Let me draw in a vertical component. It's going to be positive 51.18, so it's actually going to go up like this. And it's going to be 51.18 kilogram meter per second. Now I'm going to erase this again. So again, if you're watching this video, you may need to pause at this point and take this down. I got to pause the video for 1 second. Alright, so now I'm going to go ahead and erase this side here, or not this side, but rather just this work. Again, you can see where we got it. You can go back in the video if you need to find it again. So I'll erase that total stuff. And now what we have is a really nice looking triangle. So all we really want to do is figure out the hypotenuse now. Because again, our goal is to find the velocity and angle of this object here. So I'm going to go up like this and draw the hypotenuse. Now to get the hypotenuse of this is a momentum triangle. To get the hypotenuse of this momentum triangle, I'm just going to use Pythagorean theorem. This is a right triangle, right? You see it there. Obviously, these are a right angle. So you do a squared plus b squared is c squared. So I'm going to quickly do that. I'll take the square root of, I do it all at once. It just makes more sense to me. So I take the square root of 48.39 squared plus 51.18 squared. Now, it didn't come up in this case, but if any of these were in the negative direction, I would still just use positive when I put it into Pythagorean theorem. If you want to use negative, you can, but you got to make sure that in your calculator it's in the parentheses. All right, so for this side, once I do that, I got 70.43 kilogram meter per second. A lot of times students get to this point, and obviously they've done a lot of work, they're very excited about it, and they get this, and they think it's their answer, but it's not the answer. I want the velocity. This is the momentum. Of course, P equals mv, right? This is like the central equation behind everything that we're doing right now. P equals mv. So we know the momentum is 70.43, so 70.43 is equal to the mass of this object, which we can tell from before was 4 times v. So we just divide both sides by 4 to get v by itself. So 70.43 divided by 4, I got 17.6. So the velocity I get is 17.6, that's a pretty bad 7, meters per second. Very important. In fact, so important that I'm actually just going to put it up in the very top left-hand side for now. Alright, so we got 17.6, but we also still need the angle. Now the angle is relatively easy to get, because once we know all three sides of the triangle, you can use literally any of the three trigonometric functions to get this. But we have to use the inverse trigonometric function. I did another video talking about the inverse function, so you can look that up if you need to. It talks about trigonometry and momentum, but I'm just going to kind of go over I'm going to skip a lot of it and just go straight to, I'm going to use inverse tangent. So I'll have that the tangent inverse, oops, that's the same color, so let me change colors here. Looks like I'm connecting it. The inverse tangent of opposite over adjacent, 51.18 over 48.39. Sorry, I'm getting kind of sloppy here. I'm just trying to write in this little space. So when I take the inverse tangent of that, it should give me my answer. So I've got 51.18 divided by 48.39. And when I do that, I get for my angle, and of course this is in degrees since we're in degree mode, 46.6 degrees. So I'll put that up here as well. So theta is going to be 46.6 degrees. Alright, there's like 2 minutes left in the video, so that's the basis of it. If you can do this problem, and I should have said this at the beginning, but it's too late, you should try to do the problem on your own first, probably. If you can do the problem on your own, and then you get the same thing I do, it means you're in pretty good shape on these elastic two-dimensional momentum problems. The class that's in here right now is going to do a shout out. This is third trimester 2015, so pre-AP you can say something if you want to. They were pretty quiet. They were pretty quiet for most of the video, so this is good. Except for when one of them dropped his calculator, but I'm not going to say his name because he might have done it on purpose. All right, make sure people watch this video. See ya.